Throw your cranes up. So he's a Microsoft Technical Fellow, and he's one of the best and most influential people in our field. So it's a great pleasure to have him here give a talk, and he's interested in meeting people later. So stick around if you want to give him a talk, ask him a question or something. So he's been joining Microsoft since 1993. When he founded the speech and language group there. So he has been very influential in how to make the speech technology available to people through Windows application and PowerPoint application recently. And before that, he was faculty member at Carnegie Mellon, CMU in Pittsburgh. So he has received so many awards, and he is a fellow for IEEE ACM. So as I say, it's very hard to introduce him in a very short, moment. So please let's welcome today Xuedong for his talk today. Thank you.
Thank you. Okay, I'm very excited to be in Montreal. Sorry, I don't speak French, but I know bonjour. Okay. I want to share with you the most exciting things we're doing in speech and language. This is really the crown jewel of AI. And if you really want to actually work on something that will lead to the future, this is it. I'm glad that we have this workshop. We can exchange ideas. We can really invent something that needs to be invented. So The Economist had this cover story just 2 years ago that illustrated the speech and the language in the last 40 years. Started with IBM that had the translation research since 1950. Through that journey, it's just amazing to see what kind of milestones they picked up from speech recognition, DARPA-funded program, to most recently, Apple, Google, and Microsoft, what they have been doing in the field. So if you are interested in that, the brief history, this is actually the table through the journey. So in the last 3 years, I'm very happy to share, working with many colleagues in the community, Microsoft has been the first to reach human parity in a number of major public research benchmarks. In 2017, on the famous Switchboard task, the error rate was reduced to around 5%. This was as good as full professional people working on the same task without time constraint, and they can check notes. In 2018, once again on the WMT machine translation benchmark, we are able to translate Chinese news to English on the sentence-by-sentence basis. That's a bigger condition, as good as professional certified translation people. If you relax that constraint, humans are still doing better because they have broader context. And this year on the Stanford conversational question-answer benchmark, once again, we are able to answer questions like your participating SAT test as good as any real people. So this is the most recent conversational QA benchmark breakthrough. So those are the research breakthroughs that provided the foundational pieces for services to our customers. Of course, we have been doing this with many colleagues in the community. If you think about the product services that Microsoft offers on Azure in the cloud, we're not constrained by using fixed research benchmark data or training data. And we have utilized a huge amount of computing resources on the cloud and the data. So this is the scale of the kind of data we're using. If you look at the speech recognition, the number of words we're using to train the language model essentially is the whole web. Because we have the search engine, we index everything in the universe that's public. So it's on the trillions word level. And the number of hours of speech is 10 to the 5. it's still growing because the amount of speech transcription we can get is far less than this unsupervised text corpora you can get from the web. But that is the basis of Azure speech recognition today behind the scene. If you look at the text-to-speech, on the other hand, right now it's 10 to the 2. If in the past, you just have, one professional person coming to the lab to record 100 hours of speech has been very expensive. Today, just like speech recognition, you are not developing a speaker-dependent system. We're able to really take advantage of transfer learning. We can get multiple people coming to the lab, record enough high quality, and we can create the text-to-speech through multi-style training. That reduces the cost and increase the flexibility. And still, it's 10 to the 2. But as we accumulate more data, we expect the neural text-to-speech will be even better in the years ahead. Today, we do not have a benchmark on the neural TTS quality. That's why, I didn't actually illustrate the neural TTS breakthrough. As a matter of fact, on my Microsoft Azure Speech Services, we have this neural text-to-speech. It's already in production. That's as good as a real person for most of the people. You may not have, the emotional match. Depends on the subject. But just for ordinary sentences, to have Azure Speech to speak up, you actually see from my talk later today, it's pretty human-like. For machine translation, traditionally, we have been using parallel corpora. That typically requires 2 languages in order of 10 to the 9. Once again, like neural TTS, because of transfer learning, we're able to even start without any parallel corpora. Through the unified encoding and unified lexicon representation, we can start with 0 parallel corpora. Just have enough monolingual corpora, we can jumpstart. This is very, very important for the low-resource language. As you accumulate enough parallel corpora, we can continuously improve the quality. So our dream is really we can provide this universal translation and the language services for everyone in this planet. For 7,000 languages spoken on this planet, we should not have language barriers to really make this world a better place for us, for all of us to communicate. So that is the sense of purpose all of us have. That's why we're still working on speech and language after all those years. So big data, once again, is behind the amazing progress that Microsoft made and also all of us made together in delivering high-quality speech and language services. So I want to break down to talk a little bit about each category: speech recognition, translation, synthesis, and the conversational QA. What is we did behind the scene? So when you think about the big data, one of the really critical factors is really pick the right data. Even though you might have, 200,000 hours of transcribed data, and to cover a wide range of topics, depends on the application, you still don't have enough data or the right data. The text-to-speech is also similar. You might have, few voices fonts, but that's never the voice you like for your own. Just imagine you have, when you are a kid, to listen to the bedtime story. I'm pretty sure your mom's voice would be preferred, as always, even though you might have a professional actor or actress telling the story. But every child loves their mom's voice. So that customization is always critical to be individualized. So one of the key messages, big data helps to get the basis right, but most importantly, you need to make sure you have the right data to get everything right, individualized for the customer's needs. We have not seen the end of the power of big data. This is a chart of, speech recognition error rate. The lower, the better. The x-axis is the amount of hours we have to train the system. As you can see, this is actually reported by our colleague. Microsoft observed something similar. The more, the better. Nobody has saturated on using more data to build the baseline system. This is on the acoustic model training. For language model training, it's also similar. The most recent GPT-2 really just illustrated the power of not only more data could help, but also the size of the model could help as well. So, just amazing. A trillion word may not be enough when you have the powerful transformer. So behind the scene, we have the power of big data, the power of right data, and the amazing science of deep learning. And we reached the human parity in transcribing conversational speech on the switchboard. You might have asked, hey, what's left for all of us? We have hundreds of students here trying to participate in this workshop. And my answer is absolutely. There are many unsolved problems. For the switchboard, you have only 2 people having a conversation on the phone. And it's a close talk. If you want to open that up, you want to have ambient speech recognition. Just the smaller speakers today is able to really handle people talking, issue command, one command at a time with wake-up word. So ambient speech recognition is much harder, but the ambient multi-people conversation in the meeting is unsolved problem. So Microsoft has started looking into this a few years ago. So we introduced the first device that combined the microphone array and the camera array. As you can see, in this meeting, all of you guys, you look at the left and right, or open the eyes. Nobody actually closed the eyes in the meetings. When you close the eyes, you might be able to still understand, but most likely you will not see the body language. And what's most important, you might fall into sleep. So to combine eyes and ears together for enhanced transcription is a new frontier that we have started working on this device paired with Azure Speech. What's actually more exciting, I want to tell you, we could even get rid of the smart speakers by combining your mobile phones and the PCs. And I see a lot of people got the PCs put out. Every PC has a microphone. We can federate the microphone dynamically in the cloud to form a microphone array. That can actually really have amazing impact for the ambient speech recognition for multiple people in a conference room. So the next video is a real-time demonstration of what we presented in the Microsoft Build conference. Let me just play the video here.
Now, one service I wanted to showcase today is the Azure Speech Service. Not only is the speech service getting better and better when it comes to speech recognition. In fact, what you'll see in this demo is even for commodity hardware to replace any complex microarray setup so that your speech recognition is world-class. But the most interesting thing is when you combine speech recognition with language models that are specific to your organizational data, you can start picking up all the jargon. So imagine a transcript that gets created that has the ability to understand the local jargon that's specific to your organization, your industry, that way making the transcript that much more useful. So let's throw it to our team out on the gallery to show you speech translation and transcription.
Getting you.
The prototype device connected to a cloud service that provided live transcription and translation. We are proud to announce today that we're making the conversation transcription capability within Azure Speech Services available as a preview release. Come on, let me show you. You might also remember this hardware from last year, which we're also making available as a developer device kit. But today, my colleagues and I are going to give you a demo of new research that we believe will make meeting transcriptions more easily available to everyone in the future.
We are going to show you this demo using just the microphones built into this laptop and these two smartphones we have in front of us. With these, we create a microphone array in the cloud that enables Azure Speech Services to provide accurate, in-person meeting transcription, even without a special meeting device.
Also, you will notice that I didn't bring my phone. But the service can still recognize my voice and correctly identify me because I've given it permission to use my voice print to transcribe what I say. Now, the second thing we're going to show you is that the language model of Azure Speech Service can be trained on the data in your company's Microsoft 365 tenant, so it can learn the unique vocabulary of your industry or company. This is available in private preview.
Okay, so basically for the next 2 minutes, we're going to have a rap battle of sorts, but for all of us geeks here in the room. So Heiko is a principal PM on the speech team, and he's going to give us an example of some dev speak. And Yusuf is in healthcare marketing, and he's going to dazzle us with a little bit of healthcare tech jargon. So while they speak, I encourage you to follow along with the transcript on the screen so you can see just how powerful this service is. Heiko, take us away.
Azure Speech Services are built with VMs running on Azure hypervisors using Ubuntu-based Docker containers that are orchestrated with the Azure Kubernetes service. Azure Speech Services enable a variety of technical capabilities, including ASR, Neural TTS, Microsoft Translator, and related custom services. You can access these using your favorite programming language, such as Java, JavaScript, Node.js, C++, or C#, and others.
The bar has been set. Okay, now it's your turn to give us a bit of this healthcare jargon.
Microsoft Teams can provide EHR integration through ISV vendors, including Infor Cloverleaf, Redox, and others via the HL7 FHIR standard. HL7 FHIR is HIPAA, Mars-E, and GDPR compliant, and is based on modern technology, including HTTPS, and RESTful protocols, as well as extensible APIs. The FHIR open source community makes their source available on GitHub, and the Microsoft Teams FHIR implementation is also aligned with Project Argonaut and follows the US core profiles for all the FHIR resources it consumes.
Well, that was fun. I'm going to call that a draw. So while we're going a bit overboard there, we understand that this is incredibly important so that every company in every industry with their own specific jargon can have accurate transcriptions. We're really excited about where this work will take us, and our future ambition is to enable conversation transcriptions for anyone, anywhere, at any time. Thank you.
Okay, so that was the live demo in the Build conference in May this year. And Azure Speech Conversation Transcription is available for public preview. So if you are interested in, start using it, you can actually start consuming that as of today.
Now,
Azure Conversation Transcription is paired with the device SDK, we call the DDK. So the left is a speech-only DDK. It's typically a microphone array, either 7, 4, or 2, either linear or circular. But typically for a meeting transcription, you have people from 360 degrees. So it's important to have this circular microphone array. And all the 7 microphone array audio signals are sent to the cloud. So the really neural signal processing is performed in Azure, in the cloud. That's why when you have cross-talking, you have 2 people talking at the same time, we're still able to track and transcribe. 2 people not only tracking who said what, but also even for cross-talking, we're able to really resolve that. Without the camera, that is using voice signature to identify who said what. But when you have a large number of people, it's a little bit confusing. So it's only suitable for a small conference room, for a small number of people in the meeting. When you have 8 or more people, we recommend the second device. That is the microphone array equipped with 360 camera. So we're using audio and the visual signal together to enhance the speaker attribution and the speech recognition. And the last one is really a completely new innovation. You do not have the geometric constraint of microphone on the device. It's all dynamic. Basically, I can see this room. You have this amazing number of laptops, and if you can just say install this software, we can actually have this cloud-centric beamforming from all the devices, and then the far-field ambient speech recognition can be made easier. That's another product form, is a research prototype we are pursuing. It's codenamed Denmark because it's like a Lego. You can put all the Legos together to actually have this joined piece that works much better. So those 3 are really, research prototypes, services that are available through our system integration partner, like the middle one, and device SDK, that's a standard microphone array devices. That's a public preview. You can just get that today. So this diagram illustrates the architecture flow of what is going on behind the scene. It is applicable to either speech only or audiovisual joint speech recognition in our cloud. So for the speech only, it's the lower part. You have the microphone array. We use 7 of them. And you have 7 channels performing continuous speech separation, the reverberation, and the speech recognition, sound source localization all together. Then you form the conversation flow of exactly what you saw on the video. When you have the video camera, we have the video processing identify your face. We can actually augment speaker diarization, as together with the voice biometric signature, to actually provide enhanced quality. So that is the architecture flow of what we're doing in the cloud, performing meeting conversation transcription. This continuous speech separation component is basically a neural net, like any deep learning. When you have challenging tasks, you can take multiple speech channels together as input and provide 2 separated channels. Here, we are able to track cross-talking up to 2 people. When you have 3 people all shouting, we are not able to deal with that. But for most of the meeting, it's a business meeting. When you can deal with cross-talking for 2 people, you actually can meet most of the demands. So after you separate 2 simultaneous talking channels, we send that to MVDR to perform beamforming on their own. That is actually the neural architecture For this ad hoc microphone array project Denmark, because of the ad hoc feature, you do not have geometric constraint. We are actually relying on speech recognition to help us to perform this combined beamforming, separation, and recognition. So the audio stream alignment to blind beamforming is similar, but we are actually adding speech recognition and the diarization on top of that through this combined fashion when we deal with this ad hoc microphone array. And we have this leave one out geometry agnostic beamforming. So the mask-based MVDR beamforming is actually on top of this leave out fashion. So this MVDR approach is identical to the traditional MVDR through the weight. But what is unique is we're having speech recognition through multiple channel with recognizer through leaving one out in the rover fashion to pick the right good one. So that is actually the architecture behind Project Denmark for ad hoc microphone array. Here's the performance of, speech recognition of different configuration. The top one is no beamforming at all, as expected. The error rate is pretty high. The blue one is using all microphone through the rover combined with recognition. As you can see, the more microphone you have, the more devices you have, in general, the better the performance. And the orange one is this interesting leave one out. You want the diversity of the combination. When you actually perform MVDR, you intentionally leave one out, then you rover them again, combine them again. That actually got a slightly improved robustness. This was done on the standard NIST RT07. So it's pretty interesting. Of course, there's still a gap. This blue purple here is the close-talk microphone. So when you have ambient speech with far field, even if you can steal everyone's laptop, it's still not as good as the close-talk microphone. So this last chart I want to illustrate here is the combined impact of front end and the back end. So you can see beamforming with error rate. When you have no beamforming, it's 27. When you have everything combined improved, you can reduce that error rate down to roughly 22%. Of course, the close-talk microphone is the oracle number of 14%. So I hope that from this workshop, all of you guys, I know you have this ad hoc microphone array working session. You can push this further to close the gap. So I look forward to hearing your result this afternoon. I know we have an active working group, working session, dealing with the same problem here. So that is the high-level summary of what we're doing in Microsoft, dealing with ambient, far-field, multi-people conversation transcription. We're using a wide range of devices from both standard microphone array with computer vision, and the dynamic microphone array of your mobile devices and laptop. Now, I know we have a working session on translation as well, so I want to talk about what we're doing in translation and Microsoft. So this chart illustrated the Azure translation services quality improvement. The blue one was what you guys experienced if you used Microsoft Translator last month That was the blue quality. So we recently upgraded from the blue to red across all the languages. You can see there's a consistent improvement across all the major languages. It's pretty impressive to see a consistent improvement through this transformer-based neural translation. We used the similar recipe we had in achieving human parity, translating from Chinese to English, so that the recipe is adopted in providing Azure translation quality for those languages. We got a consistent, amazing improvement. So the basic technology is summarized on the left. It's a transformer-based core engine. We use the dual learning. You basically translate from one language to another, and you want to translate back to make sure you're constrained. Essentially, you double the amount of data you have in improving the quality. And we have multipath decoding, and of course, the right data, as I said, is super, super important. If you have the garbage in the data, the quality will suffer. So if you have not used Microsoft Translator, install that today, you'll be able to enjoy the blue, from blue to orange or red across all the major languages. So what I want to talk is really, yes, for the major languages, we can get a lot of parallel data, improving the translation quality. What I really want to talk about is we have 7,000 languages. We do not have a lot of data. What can we do? So, as you know, the Rosetta Stone story is just inspiring and fascinating. We had this British scientist. He started decoding Rosetta Stone, and eventually the French had a breakthrough. We are able to decode this ancient Egyptian language. Because of that stone, we can see the ancient Greek. Even though it's a very small amount of data, well, finally, British and French working together had a breakthrough. We're able to really decode this ancient Egyptian language. So that inspiration is absolutely driving a lot of research we have here. Actually, we want to move beyond Rosetta Stone story. With our Microsoft Translation latest universal translation core engine, we're trying to create this universal translation system by leveraging all the data we have. Now, by the way, this French guy and the British guy, they were able to speak, I think, 10 languages. Very similar to Microsoft translation system. If you do not have the skill to speak 10 languages, it's almost impossible to decode, decipher this ancient Egyptian language. So, of course, Microsoft translation system, we are able to translate the 60 languages better than the French guy and the British. By the way, this British guy is amazing. He was a doctor, graduated from University of Edinburgh, did all those fancy decoding work, published a lot of stuff, but he always used the anonymous name to fear that his medical career can be jeopardized because he was doing something totally irrelevant to what he was doing. His last name is Young. You can check. Not Steve Young, Thomas Young. And he had medical training from University of Edinburgh. I'm proudly alum from myself as well. So with 60 languages, we want to know, can we leverage those languages, all the encoding, decoding skills you accumulated? Here's the architecture we have that was published last year. We want to have this universal lexicon representation, leveraging all the languages we have accumulated. So the study, what we had was, we had English as the common anchor. we have Spanish, French, and Italian. We have reasonable amount of data. Now we're tested on Romanian and the Korean. One is similar to the European languages we have. The other is really, kind of different. So we created this system that will map Romania into the internal representation through this embedding. Because for the translation system, you basically map to the encoding, then you decode. You also have the sentence structure you can share from the decoding. So through this joint mapping, it's actually just amazing to see we can really improve the quality. So if you use only about 6,000 sentences, look at the blue line. This is just, you are using standard recipe to train your translation system for Romanian. And you need roughly 600,000 to get to something that's decent. So the multilingual neural translation is the orange one. By leveraging what we have in Spanish, English, Italian English, French English, we're able to really help the low resource language. What's actually cool about the green one is with a universal token, the embedding improvement in the paper we summarize, we can actually get amazing result, even without parallel corpora. So this is more powerful than Rosetta Stone story. Rosetta Stone, at least you get this ancient Egyptian language and Greek. It's a small amount of data to jumpstart. With this universal encoding and the universal lexicon representation mapping, of course, with our language pair, you can get to the point of roughly 15 blue score. With additional parallel corpora, you can continuously improve. And that is the dream we have. Through the transfer learning, this is actually, I think, we're going to have a very profound impact to the society. We can leverage this reasonably accumulated parallel corpora by leveraging that for low resource language. We hope we can rapidly improve the coverage of our translation system. So there are some typical tricks that you have to apply, like you need to fine-tune on the bird-enabled model, and through fine-tuning, you can further improve. Here's the result of our multilingual neural translation system in the real-world scenario. You can see that without the multilingual transfer the learning, you got essentially the blue for all those no-resource languages. Through the leverage of transfer learning, we got massive improvement. And this is for the Indian languages we are covering. You can say they are kind of similar. Yes, in this planet, there are actually a few bigger languages we can cover. We would have the parallel corpora. But there are, other languages that are different, but they are similar. We can leverage the transfer learning. So I want to actually add the comment for the Romanian, we got a massive improvement. If we just add the Korean, which is very different, we also got the improvement, but the absolute quality is still not as good. So if your transfer learning starts with the language that are similar to the language you want to expand, your quality, for sure, is going to be much better. But regardless, transfer learning still helps, even for a language that you have never seen, and even for a language that's very different. Last but not least, I want to talk about this year's WMT benchmark. Microsoft Translation got the amazing coverage and top quality for multiple language pairs. And there are some exciting new underlying technology we developed. One is this multi-agent dual learning. You basically want to have multi-agent to essentially to learn the constraint from different agents, not just one agent when you do the dual learning. And just inspired by BERT, we have this masked sequence-to-sequence learning that's actually more suitable to the sequential performance. This was also published. And the last is the document level translation. Without doing much, if you can just expand your translation context, instead of have this sentence-based translation, you expand to the whole document. And we have seen the amazing improvement of the quality. This is just, once again, the data and the context really helped the whole system. So for the multi-agent approach is very similar to the dual learning we have introduced in the human parity system. But this one, we just have different agent. We combine all of them together with the same constraint. That gives us a very decent improvement. On the sequence-to-sequence pre-training, you have a staged approach, like a deliberation. We can actually make an improvement. Here is the BERT-inspired mask that actually expands beyond the BERT. It's using sequence-to-sequence to improve the overall quality. So here's the result on the WMT 19 between English and French. Oh, no, English and German, I'm sorry. You can see the improvement of, from the baseline, which is blue to orange. That has back translation. The gray one is the one with MADL. Okay? So that is the overall summary of translation. We are improving underlying science. We are selecting data carefully. I'm most interested in exploring the transfer learning to cover all the languages. That's amazing to see the capability of transfer learning. So I'm pretty sure we can move beyond Rosetta Stone impact. So for the next one, I want to briefly talk about the Conversational QA human parity milestone. This was actually mostly built on BERT. So for Conversation QA, you have the input, you have the question and answer. Through BERT and the fine-tuning, you are able to get the right answer from the paragraph. So we added additional data. In addition to the squad and the CoQA data, we added the news QA, multi-NLI, and we also had very similar to deliberation network in translation. We have this multi-stage fine-tuning that really fine-tuned and improved the quality. And the last but not least, we added the auxiliary language model. That just pushed the overall quality to the level of humans level, another important task. Once again, this is the task of Conversation QA for Stanford Challenge. We love to see if we can expand this to generic conversational application. So for text-to-speech, I didn't include that in the human parity milestone on the public benchmark. How much time do I have? 10 minutes? All right, I will accelerate. So text-to-speech went through something very similar to translation speech recognition. On the traditional text-to-speech, you have some very customized, complicated system of so many different modules because you have to deal with language, acoustics, and the prosodic information. On the left, the purple one is the new neural TTS infrastructure that really simplified the whole system through the end-to-end learning. Once again, like speech recognition, we are able to pull different people's voice together through transfer learning, similar to the translation achievement we talked about. Through this speaker encoder and the embedding module, we are able to really observe substantial improvement, not only because, we are more flexible, because in the past, it's always expensive to get one person coming back to the lab through a long period of time, because the professional person cannot record for over 1 hour, because the person needs a rest. And through the time to gather, a huge amount of data, the voice also changes because the person is getting older. So the quality control is always challenging. The system is very fragile. Now, through the transfer learning, we're able to really, reduce the cost of recording and improving quality. But most importantly, we're able to introduce the attribute to change the style, change the, language even. Given the time constraint, I will just skip those, jump directly into my voice. And we can customize my voice. Now you heard my voice. Let me actually play a few voices. I do not speak German. I do not speak Japanese. Let's see. I only speak, even for Chinese, I do not speak Chinese with Sichuan dialect. So the deep learning is able to really manipulate my voice with different attributes and with amazing impact.
The triumph of the grail is also the triumph of the sun.
So that was not what I said. It's dangerous, but it's what computer synthesize. Because you heard enough of my voice, that sounds like me, right?
春节期間，百年嚟斷線漫天飛，吉祥嘅華語傳遞咗人們新春嘅祝福。
So if you speak Chinese, this guy actually speaking with Sichuan dialect. But I'm not from Sichuan, by the way. And they just manipulated it, had me translate, my voice translated and speaking with a different dialect.
Mit dem Angeklagten habe ich auch kaum gesprochen.
You speak German? So that's actually my voice speaking German.
およそ極楽とは縁のないもの。
And the Japanese. I'm able to speak 60 languages freely with my dialect and style. This is the power of transfer learning and neural TTS. And to close on this one, I want to share with you the latest event Microsoft just had. We had this amazing HoloLens that can capture your digital hologram and have your voice synthesized, speaking a different language. So Julia White, she is our marketing leader in the company, and at the conference, she was able to present in Japanese. I can tell you, she doesn't speak Japanese. She is American. And let's actually see the video. Also,
Let's get started. First, let me introduce you to Mini-Me. There she is, my perfect holograph. And thanks to the power of HoloLens 2, she just floats right with me. I'm literally holding my hologram, so natural. Now she's a little small to do a keynote. So let's get her up so she can do full-size Japanese keynote. Render keynote.
So this is the view from hologram.
ホログラムになることには本当に驚くべきことがあります。私たちは最新の複合現実キャプチャ技術を使用し、私のホログラムを作成しています。実在の人物をホログラムとして見たことがあるかもしれませんが、私が実際に日本語を話しているのが新しいのです。私は日本語を話しませんが、私の声とホログラムは完璧な日本語で話しています。これはニューラルテキスト読み上げと呼ばれる最新の人工知能技術、いわゆるニューラル TTS を使用しています。私たちは自分の声の録音を使用し、私のように聞こえる私自身の個人的な音声署名を作成します。 日本語からフランス語、ポルトガル語まで話せます。今、この技術は私たちが働き、遊び、生活する方法に関して、世界中の国境や障壁を取り除くことができると想像してみてください。まさに SF が現実になるところです。
So this is the public yesterday, so you can actually watch that yourself if you.
Let's get started.
So to end this, I want to really highlight all of us made this amazing progress in the last 30 years, especially on the speech recognition, neural text-to-speech, translation. And I'm mostly passionate about translation because it is somewhere between perceptive intelligence and the cognitive intelligence. You can say speech recognition, computer vision, neural TTS, they're all at the perceptive level, right? There's no understanding, there's no reasoning, there's no knowledge acquisition. But still, this is just amazing to see we're approaching humans' capability. Translation is somewhere in between. We pretend we understand, we translate. And still, we're doing a reasonably good job. But the real challenge for AI is on the cognitive intelligence. The ability to acquire knowledge, ability to reason, to understand, comprehend is going to be the ultimate challenge for all of us. And I want to quote from Judy. He is the Turing Award recipient, a professor in UCLA. He had this amazing book, The Book of Why. I made a copy of what he had in the book. You can see there are 3 levels of intelligence. And the first level is all about association. That is where the personal assistant or robots are, right? And the second level is intervention. And the highest level of intelligence is imagination, counterfactual. So all the neural nets, you have a bunch of weights. You train the weight mostly on the association level. So that's where we are to conquer this amazing challenge, to fulfill the dream we have. Despite of that challenge, but I'm very optimistic, we are having roughly 7,000 to 8,000 languages spoken on this planet. If you look at the GDP, Microsoft, we're able to translate among 60 languages. That's 95% of the world's GDP. But if you look at the diversity of the language on this planet, simply stunning. Through transfer learning, deep learning, data acquisition, the dream is really, let's actually get rid of the language barrier to make this planet a much better place. When you have no language barriers, we'll be able to understand each other better. We'll be able to remove differences better. We'll remove bias. So this is the sense of purpose all of us have. You're absolutely in the right field, working on speech and language. That's my end of the talk. Thank you.
All right, thank you, XD, for this wonderful talk and inspiration. So, do you have any questions? I think Lane, can you start the microphone there? Put it up.
Yes,
Testing?
I can hear you.
Okay.
Yeah.
Thank you very much for a wonderful talk. I'm working in one of those, in the language processing, in one of those 7,000 very, very low resource languages. Could you go back to the slide where you were talking about the multilingual adaptation? In that slide, you talked about needing only 6,000 or 7,000 parallel sentences in a new language to adapt. What amount of training data did you have in the other languages in order to get those kind of numbers?
And the other languages we have, it varies from 1 million to 10 million.
Okay.
Yeah, because for all the tier 1 languages, we have accumulated enough data. When you have 100,000, probably you'll have good, decent quality. So it varies for English to Chinese, English to German. Those are the two best quality we have in Microsoft Translation Services. We use roughly 10 million.
Okay, so the numbers you showed on that chart were 6,000 or 7,000 for the low resource pair, but very high numbers for the other systems other languages that was trained on.
So even for Romanian, when you have like 20,000 parallel sentences, that's the golden standard. So multilingual universal translation is still worse than the language you are trained with more data. So we're not reaching, I'm not claiming by using universal translation, we can actually outperforming the language pair that got enough data. But the challenge is that for 7,000 languages we have, we may not have enough, like 100,000 parallel sentences. So to jumpstart, to actually provide that basic function, then gradually adapt, learn, improve is our dream, is our strategy. So create that universal translation system, even without any parallel corpora. You can have roughly 15 blue points. You can start using it. You can, remove language barriers, start from there. As we accumulate enough data, we can gradually close the gap. That's why we can actually, I hope we can team up with everyone in the community. Let's work together to remove language barriers, to cover 8,000 languages spoken. So we have not solved the problem. The real dream is really through universal language translation. We could actually be as good as a language pair that is, with 10 million sentences. No, that's not the case. Even with 100,000 sentences, you are trained between English and Romanian with 100,000 will be still better today.
Okay, thank you.
Okay.
Well, you can go there.
Thank you very much for the wonderful talk. And I'm just having a question in regards to the first part. When you do the speech transcription in the demo, it seems like there is no punctuation when the text is generated. And also it seems to me it's like multiple words are like spaced out rather than one word by another. I wonder if there is some reason like why the setting is like this.
There's no reason. That is just the limitation of our technology. Right?
Okay.
So we want to add the punctuation, but we have to make a guess. That requires both prosodic and the semantic implication.
Right.
Because people are not really, when they are in the meeting, they're not talking about, with speech, adding a punctuation. We have to see the semantic meaning of the sentence and the prosodic information, how long is the silence, then add that punctuation automatically. That's the current approach we're taking.
Okay, thank you. And a general comment, I'm very impressed by the hologram. It feels to me like the newest episode in Black Mirror. And I feel like this can, well, if you have watched it, so this can getting I feel like probably in the future, maybe you don't have to be physically here, just send your hologram and speak English here where we have Japanese equivalent version. So yeah, I just want to say
if everyone wears Microsoft HoloLens too, yes, absolutely. And
all right, thank you.
Thank you. So before I end here, since we are more relaxed, I want just actually to tell you, I'm in Montreal. I respect the tradition. I'm sorry, I don't speak French, but PowerPoint actually already had English to French built in. If you have the latest PowerPoint, you can see always use subtitle. You can say it's French. Actually, this can translate into one of the 60 languages. I picked French because I'm here, right? And when I present, I should be able to speak French as, I don't know. I have no idea what I'm saying. But my subtitle is in French. I hope it's in French. So this is really in production of the latest Microsoft PowerPoint. If you give a talk in Turkey, you can speak in French, and the subtitle will be in Turkish, or Greek, or Mongolian. So feel free to use it. This is a sense of purpose, as I said, to help everyone on this planet. The only bad news is we only support 70 languages. We need to multiply that by another factor of 100.
Oh, no, not bad.
Thank you.
All right, we still have some time for more questions or aspirations, you know.
Well, I'm just wondering, there's a lot of effort nowadays, especially in companies like Facebook, that they are trying to fight against the deep fake. Since you have like these beautiful synthesizers, are you also working on that area on how to avoid?
Yeah, it's a wonderful question. Microsoft is taking AI very seriously. We have an ethics society committee examining everything we're doing. For example, we have this customization capability of our neural TTS. We shipped the customization TTS using old technology. It's not as good as neural TTS. But for neural TTS customization, neural voice customization, you can really get the 30 minutes of a person's voice, upload to Azure, then, my God, you can force a person to speak anything you like. So there's a huge amount of ethical implication. We are introducing the code of conduct on how we should actually enable customers using that technology. So this is a work in progress. We are aware of all the challenges you talk about, yes.
How is the humanity going to suffer from our technology because we created the fake audio?
Oh, I think you can look at this from productivity point of view. What if your child can actually enjoy mama's bedtime story? That's the positive side. I think you can raise the family more effectively by saving time. And or you have an anchor person. The anchor person is sick. You need to get someone else. The BBC radio could have continued. Even the person is sick. So it depends on how you want to regulate. Introducing code of conduct. We want to have a responsible approach. So that is actually work in progress. We're not rushing to get those tools out. I know Montreal has a startup doing the same thing, right? And using neural TTS to customize for different voices. So we're going to face the same code of conduct challenge in dealing with synthesized media. Actually, this is a broader problem, how you deal with synthetic media responsibly. Anything else? Yes.
Okay. Hi, thank you for the conference. I want to know if we want to start working in the translation field, what kind of study or what should we do to start in that field?
Okay. Translation, like speech recognition, text-to-speech, they're all similar. And you just have this amazing skill. You have to be good at math. Neural nets is nothing more than just, linear algebra operation, right? Differentiation. Nothing special. So be extremely good at math and extremely good at programming because you need to run thousands of experiments. Most of them will not get anywhere. 95% of them will fail. And you have to have endurance. Willing to get your hands dirty, willing to really suffer from the failure. So those are the three skills Microsoft is looking at. If you're good at math, you're good at programming, you're willing to work hard and tolerate the failure, you're a good hire in general, because everything is going to be new. What I learned in graduate school, if I look at what is being used today, 30 years from now, 30 years from what I was doing, most of them are gone. But the math, programming, the attitude, I think they are more or less the same. So we are hiring. Next year, we're going to actually add 50 people to the speech and language group. So this is great news to the students working in speech and language. So applied to Microsoft, let's actually join the force to remove language barriers for this planet.
I have one more question, and actually it's not for me, I'm asking for a friend.
Okay.
As always. So all these achievements you are showing, they depend on immense amount of computational power, right? So what would you say to, let's say, a junior scientist that is starting to work and in field of, let's say, machine translation on ASR, or let's say machine learning in general, and doesn't have 600,000 GPUs available for his experiment?
Well, I think you can always constrain your research like a zero-shot adaptation. You can take a Microsoft open source. Microsoft, by the way, just open source BERT capability on Azure. So you don't need to retrain the whole thing. We not only open source BERT like Google, but we also open source the data. So you have the same data we used to train BERT. That wasn't available before. So Azure offers an amazing amount of GPU. I think universities, they got some discount. I know that the Stanford the AI class, all the students are using Azure because of Stanford and the Microsoft agreement. So I don't know for other schools what is the situation, but clearly you can frame the research challenge to build on the success of industrial offering. Like we packaged all the APIs on the cloud. We offer the customization for translation, speech recognition, and the text-to-speech. So the questions I'm back to professors is, what is you can do? Build the success of your research on Azure speech, Azure translation, and focus on problems we all face together. We need to continuously improve quality. Microphone array is still a challenge. You can see the gap between close-talk microphone and Project Denmark. Even with all the fancy cloud-based beamforming, with the recognition, with the computer vision combined, there's still 30% gap, right? When you have no data, when you have a small amount of data, like only 6,000 Romanian languages, parallel corpora, you are still not as good as if you have 100,000 parallel sentences. So the challenge remains. It's actually fantastic to be in the field of speech and the language. Not to mention, you want to add a conversation, understanding, reasoning on top of that. That's just going to be, unlimited problems we have to deal with. So I guarantee for the next 30 years, you have a job.
Thank you. I have a question. When you do transfer learning, if the target data set has few labels or even no labels, how can you improve their accuracy? Yeah.
So when you have no parallel corpora, you essentially only map your language into the embedding of common tokens, and you leverage the rest of the system. So you can get roughly 10 to 15 points of blue. Word-to-vec embedding is unsupervised. That's the first step, right? And you can also compute the embedding based on the similarity. We have the mixture language experts to actually help you to identify the closest one. When you have the constraint of the monolingual corpora, you still have the constraint of the language structure. That structure can be associated with whatever tokens we have, in the current embedding system, and then leverage the existing universal translation system to translate it into English and other languages. It's not the perfect one, it's a starting point. And the small amount of parallel corpora, they will actually play a very essential role, like a Rosetta Stone. So you can actually take a look at that paper of our multilingual universal translation.
Hello.
Hi.
Yep, technology is working, good. First of all, thank you for your talk. I'm coming back to the point of you can do this translation capability in 60 languages and you want to go to 6,000 languages, right? So it took us 50 to 60 years to get here. Given that some of the 6,000 languages, there is only one speaker left. So I'm kind of curious, what are your thoughts on how long is it going to take us to get to the point that we can cover the 6,000, and what do you see as the main hurdles?
Yeah, that's a fascinating question. I think the answer depends on the quality, right? If you can tolerate with 15 blue points, you can accumulate enough monolingual corpora and build the system into the universal translation framework. And that also depends on whether your language is similar to one of the existing languages we have. I would say monolingual is the starting point to jumpstart everything we have. You still need a small amount of parallel corpora. I believe to have the ability to translate, have Rosetta Stone kind of inspiration is important. Get the 6,000 parallel sentences, and that's a jump start. That amount of resources can be achieved by all of us working together. So we need a community-like approach, open source sharing everything, and because by removing language barriers, we can make this world a much better place. It's not for the benefit of one country, one nation. It's really for all of us.
I completely agree. Personally, I have the feeling it might be something like the 1990 challenge. We've done 90% of the work, and because of the scarcity of the other languages, and they're very different, and they're polysynthetic, and God knows what else, it will be an interesting challenge for the next, well, several decades.
Yeah, I hope it's not several decades. Really, just if you look at how long it takes for new technology to get adopted, it's getting shorter and shorter. So moving forward, I really am optimistic. It will not take 30 years to cover 7,000 languages.
Sounds good. Thank you.
Thank you.
Yeah. Thanks. Hi. Is emotional state one of the attributes used to improve speech recognition?
I'm sorry?
Is emotional state, or just, I guess, a little bit of affective computing?
Emotional states, I don't think so. I don't think we're using that emotional states explicitly in recognition. That might have been reflected in the huge amount of data we have, but we do not model that intentionally.
And, okay.
That's interesting, yeah. Just there are so many dimensions of, people, right? You have accent, you have emotional reaction, you're angry, and just the implication of that is multidimensional.
Yes.
That's a good question. I do not know.
Yeah, it's very interesting because I think it would really help absolutely increase the accuracy.
Yeah.
But it may come with a lot of responsibilities as well, of course. The second question, what's the largest array of microphones in continuous that you've used?
What is the largest?
Largest amount of in the arrays of microphone that you could use?
We have I do not know because I think Jim Flanagan in the old days had this massive array on the wall, right? I do not remember the exact number of microphones. Some of you guys might, but today most of the people use the 7 to 8.
Okay.
Yeah. And I want to also point out 7 to 8 microphone depends on the distances. and could be actually as good as closed-talk microphone. In our challenges, we have multiple people talking. They are in ambient environment, very noisy and challenging. So roughly there's still a 40% gap between closed-talk microphone and the 7 microphone array. When your distances, ranging from 4 to 10 meters, that's fairly challenging. So that 40% gap is a research challenge. I hope after this workshop, we'll see, a new direction. That's the I-vector moment I was just asking. Do we have an I-vector moment from the workshop?
And just one final question. So there's in your news translation slide, there was an improvement from 2018 to 2019 for almost all the countries between 1% to 9%, but Korea jumped about 22%. Was it suddenly more data, or was it?
Mostly more data.
Yeah.
Data. The power of data is just amazing. As I said, with all the research on transfer learning, nothing beats a sufficient amount of data.
Right.
Yeah.
Okay. Cool. Thanks. Great
Thank
presentation.
You. Yeah.
So I just wanted to ask a follow-up question on the low-resource languages, because you mentioned in your last answer that you're relying a lot on monolingual corpora. But there are a lot of languages for which we may not have very much parallel corpora, so maybe we have, say, 6,000 sentence pairs, but we also don't have a lot of monolingual corpora. Or that monolingual corpora may be something like a dictionary or a word list or something like that, rather than the kinds of monolingual corpora that you might be able to mine from Wikipedia or something like that. Do you have any insight about the amount of monolingual corpora that you need to have to make the methods you've been discussing successful, and any sort of additional thoughts about that for languages that don't necessarily have the distribution of data sets that you might be expecting?
Yeah. I think for translation, this is text-based translation. If you have 10,000 parallel sentences, your quality will be reasonably decent. It's probably barely usable, and the more the better. So 10,000 is probably the minimum. For speech recognition, we require more to have the robustness across different conditions. For a good, decent quality, we need a transcription roughly 10,000 hours of speech. So that is the ballpark. That is the bare minimum starting point. For the more the better. If you have 50,000 hours, clearly it's better than 10,000 hours, right? The more the better. So when you have 10 million, that's what we're using for high quality translation. So 10 million to 10,000, that's a huge gap, but 10,000 is probably a starting point for a low resource language.
And so that also includes the monolingual corpora that you're using. So for like the Romanian example where you're talking about getting reasonable quality scores with 6,000 lines of parallel text, how much monolingual text are you using?
We used all the data from Spanish to English, Italian to English, and French. But those varies, from 100,000 to a million. And also we added Russian. Russian and Romanian, they belong to the same language family. So once again, in that experiment, I want to just emphasize Korean was in the range of 6 blue points because they're so different from the auxiliary language in the system. We added Korean just to see the universal multilingual translation still help from no resource Korean to English translation. But, it was like from 4 points to 7 points. But still moving in the right direction. But it wasn't as good as Romanian that reached like, 15 points quickly.
Thanks for the presentation. My question is, can we use synthetic generated text to train machine translation models, or?
Absolutely, yeah. This is, once again, if you have good, reasonable quality translation system you can. So to jumpstart, that is the challenge for the resource language.
Okay, thanks.
Yeah.
So, all right, let's thank XD for his wonderful time and his patience to answer all this question. Thank you so much. Thanks for being here.